Good afternoon, everybody, and welcome to our first From the Field Farm Chat with Idaho Wheat for 2025. I appreciate all of you joining us today and hope that you will find value in our conversation today. We are privileged to have Kurt Schroeder from the University of Idaho. Kurt is an associate professor with the University of Cropping Systems Agronomy and Plant Pathology. And today we are going to just have a conversation, learn from Kurt about threats to our wheat, wheat disease threats, specifically stripe rust and soil-borne mosaic virus. But before we get started and I turn the time over to Kurt, I just want to remind each of you, if you have a question, please, we welcome questions throughout this conversation. Raise your hand or unmute your mic, and I will make sure we get to you to ask your question and get that answer from Kurt. So Kurt, if you want to go ahead and take this away, appreciate you being here.
Sure. Great. Thanks, Ryan, for the introduction. And just to give a little bit of background about myself. So I have a bachelor's degree in microbiology from the University of Idaho. I stayed on at the University of Idaho and did a master's degree in plant science, but again, with an emphasis in plant pathology. Working on a couple potato diseases actually is where I started out at. So working on a bacterial and a fungal disease. I then worked with the USDA for about 15 years in various capacities as a technician, 4 years as a PhD student, obtaining my PhD with Tim Politz at Washington State University, where I worked on soil-borne diseases of cereal crops, primarily Rhizoctonia, Pythium, and take-all diseases. I postdoc for another 9 years, again, continuing to work on various fungal diseases, primarily of cereal crops, and then joined the University of Idaho back in 2013. So I've been with U of I for almost 12 years now, and I do research in cropping systems agronomy, primarily looking at soil acidification, solutions for managing soil acidity, agronomics of winter pea production, and then I manage the North Idaho variety testing program for small grains and grain legumes. And in addition to that, I'm also still dabbling in some pathology, doing some work on seed treatments and education on various disease issues in the state. So should we just go right into the stripe rust then?
That's great. Thank you for that.
Okay. Yep. Sure. So we'll start off with stripe rust today. I'll be talking about stripe rust and then going into a little bit of a discussion on soil-borne wheat mosaic virus. Both of these are diseases that are either chronic problems in northern Idaho or relatively recent introductions in the case of the viral disease. But stripe rust, this is a disease in the Pacific Northwest that we deal with every year. As growers, I'm sure most of you are very familiar with this disease and what the symptoms look like, but just in the interest of being thorough, I thought I'd give just a brief introduction. So it's a fungus called Puccinia striformis that causes stripe rust in wheat. It's favored by cool, wet conditions, which we have every year in the spring. Temperatures between about 50 and 65 degrees are really optimal for disease development. And the disease can build pretty rapidly with those temperatures, with free humidity or rainfall or humid conditions that persist throughout the day. The disease can build up pretty quickly with new generations about every 10 to 14 days. So the disease, as you know, can build up pretty quickly. The disease starts out as typically these chlorotic patches on the leaves. As the fungus develops inside the plant, it'll start producing the spores, the uridinospores, which are that yellow to orangish color you'll see on the leaves. On your seedling plants, that's going to appear as more scattered pustules across those leaves. But as the plants mature and you start getting to the jointing stage and beyond, you can get the typical striping on the leaves where you'll actually see the lesions restricted by the leaf veins, and you'll have these longitudinal stripes on the leaves with rows of the yellowish orange colored pustules on the leaves. Now, the disease varies from year to year, the severity of the disease. A lot of that has to do with whether there's inoculum that survives within our local area or whether it has to recolonize the region. When we have our typical cold winters, most of the inoculum in plants locally will die off. The fungus can survive down to about 14 degrees inside plant tissue. Below that temperature, it'll die off. And so the only surviving inoculum in the region is typically going to be in the Willamette Valley or some of the areas along the Columbia River where there's warmer temperatures during the winter. And then that fungus has to come back into the region and recolonize. In winters where we have relatively mild winter, such as we've been experiencing most of this winter until the past few days, where we have warm conditions, the fungus can persist in these locally infected plants, and there's inoculum readily available in the spring, and there's a potential for more disease. So in order to kind of get an idea of how severe the disease may be in one year versus another, there's been forecasting models that have been developed. Xiaoming Chen, who is a scientist with the USDA, ARS, and Pullman, has developed, or he has worked with a team to develop one of these models that's used in the Pacific Northwest. And it's based primarily on the winter temperatures from November through February. So the first forecast, there's like a mid-season forecast that comes out after the November and December data is in. That came out here a week or two ago, where Xiaoming was expecting that we're going to have a potentially a severe epidemic this spring based on the mild winter we're having so far. That model is then going to take into account data over the next 2 months. So if the winter turns cold now through the rest of January, which there's not a lot of January left, but more so into February, we have the potential yet to reduce some of that inoculum potential and maybe a downgrading of that severity that is being forecasted for this spring.
Hey, Kurt, on that note, I wanted to follow up a little bit. I mean, Xiaoming's first report was pretty scary, saying we're in for a pretty severe year. You've also had some pretty nasty temperatures lately. What are your thoughts now about revising some of that outlook? Do you think we've knocked it back a little bit?
Well, I think there's the potential that we have knocked it back a little bit here in the last week. I think we're kind of right at that cusp of where we could start reducing some of that inoculum. I think the other thing to take into account is that the last several years, we've not had a lot of stripe rust pressure. So there's not been a lot of disease building up. There is the potential that we've had some fall infection. There's that potential every year, but I don't think we necessarily have that big reservoir of inoculum that was present in the fall to get the big epidemic going. But that being said, with the mild conditions we have had, there is that potential. If we continue to have some cooler weather over the next few weeks, I think that could help in downgrading that severity index.
Right. I mean, and some of that stripe rust originates in California, really, doesn't it? I mean, and it's been really dry down there. So maybe we start off with a fairly light inoculum load maybe this year.
Yeah, my guess right now would be kind of in the vicinity of a moderate, potentially, based on the temperatures and the conditions we've had.
Do you have a sense of what temperature it takes really to knock stripe rust back down in the winter?
I guess it's not a disease
or...
I work on specifically, but just my general knowledge of it. We need temperatures in the low teens.
Yeah.
I don't know how many days we need of that. I don't know that one night's enough to do it, but
right.
We need probably a few days where we get some of these colder nighttime temperatures, and we have had some of that recently. So I'm sure that's going to help kind of downgrade that forecast.
Right, and that's kind of the temperatures I was thinking of as well. You don't have to get below zero to knock it down. The
No.
teens ought to help a lot if that works. But you guys have had pretty good moisture this fall, so that's been a good start at least to the season. So we'll keep our fingers crossed a bit, huh?
Right. Right.
So Kurt, another question obviously the biggest problem we have, well, from a breeding standpoint, the biggest problem we have with stripe rust is changing races. And it's too early, I'm sure, to get a sense of what race changes or what kind of varietal responses we're going to get. But is there an early look or early warning on what some of that might look like or when that might happen?
I think that's an ongoing process. I worked in the lab right next to Xiaoming Chen's group, and I know he gets samples throughout the year. I'm sure he's already collecting some samples from some
Yeah,
of the fall infected plants. I don't think they've done a big survey, but they have collected some plants, and I know that's an ongoing process throughout the year where they're looking at the stripe rust that's in the region, they're typing it to determine what races are present. So that's an ongoing process, and I think that happens throughout the year. I don't know
sure.
that we've got any sense of that. I don't know that last year, I don't believe there were any new concerning races that developed. It's not something we're going to necessarily see every year.
Right.
And I know from the plant breeding side, I know that's probably one of that's an area that a lot of our plant breeders really focus on, as you know, and incorporating in both seedling resistance as well as the high temperature adult plant resistance, which really is a more durable resistance as our temperatures will start warming up in the summer. But I know there's been a little bit more of a concerted effort, I think, in recent years as well to put in multiple genes for seedling resistance as well, which can help overcome that breakdown in resistance if we have a race shift.
Right. Yeah, I mean, it's a dynamic disease, obviously, and so the more genes, the more seedling genes you can put in there to suppress the disease is always the better, no doubt. And the high temperature adult plant resistant genes have been effective. I've still argued that they're somewhat race specific as well. So there's something to go with that. But all I know is a lot of breeders, including myself, have probably lost a lot of sleep over the years with some of these changes in races, and a
Right.
lot of the seedsmen as well, I'm afraid. So the early warning, the better, that you can get at these diseases as quickly as possible. So Kurt, would you talk just a little bit about, obviously with an early alert like this, I mean, farmers are going to be start thinking about, okay, when do I need to start looking at fungicides? Do I apply them with regular herbicide applications, or what's kind of the state of the art right now in trying to manage the disease through fungicides?
Right. Well, I think based on the forecast that's out now, I think growers, if you're growing a moderately susceptible or a susceptible variety, I think you certainly need to be putting it on the radar to think about putting that first fungicide down at the timing of herbicide application, getting that early season fungicide on. If we have conditions that are conducive for the disease, these prolonged cool, wet conditions this spring, I'm sure it's going to take more than one application in these susceptible varieties to manage the disease. But I know as a pathologist and one who does science on the research on these issues too, I encourage growers to let the genetics do work for them. So if they're working with varieties that are highly resistant, they're rated as a 1 or 2 on that
Yeah,
rating scale and have got really good strong resistance that you don't need to spray those. You certainly don't need an early season spray. Maybe keep an eye on them. If you see rust developing in them and you're getting pustules forming, maybe we have had a breakdown, maybe you need to spray it. But we've got really good genetics out there. There's some really good resistant varieties. And, I hate to see us lose a tool by overusing a fungicide. So I don't think we need to blanket apply fungicides to all of our acres at herbicide timing. But, if you're dealing with a variety, has got some susceptibility in it, it would be a good idea to put down that early season application.
I think that's a great message because you're exactly right. We don't want to overuse fungicides that we don't have to, and there is a tendency to take action when maybe it's not necessary. And these early warnings of people being alert to what's going on around them and listening to the alerts from you and from Jiaming, that should give them enough warning to be able to react appropriately. So that is important.
And I'm expecting, based on the temperatures we're having and based on what we may see over the next month, that this may be downgraded. And, we've seen that happen in previous years as well. So we'll have to wait and see. If you're not on that alert that alert system that Xiangming puts out, or you don't get that forwarded to you by any other group, let me or somebody with the Wheat Commission know, and they can connect you with that, because it's a great resource to do some early season planning.
Absolutely. No, that sounds great.
Just a quick question, Kurt. Are there specific characteristics and varieties that make them susceptible to this, to stripe rust?
Characteristics of the varieties. Well, I don't know the specific details of it. You know, a lot of the seedling resistance, that's a gene for gene resistance. So it's genes in the plants that are conferring resistance throughout the entire lifespan of that plant to the pathogen. You know, some of the adult plant resistance, I don't know the specific mechanisms, but and Jim may have a little bit better idea on that, where he's done the breeding with that. But you know, I don't know how much of it's physiological and how much of it's genetic.
Yeah, and there's some of it may just be, anti-nutritional factors for the fungus too. You know, but we don't really know what all is behind some of that adult plant resistance, and that's why it's a little sometimes easy to take it for granted because we don't really know how, but it has been long-term effective. That's important.
Right. I think Corey. Oh, there he is. Yep.
Yeah, I kind of had a question while we were talking on that temperature. Kind of thinking about it, we always get in Southeast Idaho below those temperatures, and I kind of always assumed that, oh, we have an outbreak about one out of every 5 years, it seems like, when temperatures are conducive in May and June. But are we living that under the snow? Possibly. I mean, we almost always have snow cover. Is it surviving, or is it transport that we usually get those outbreaks?
Well, you know, the snow is certainly insulating our crops, and it can do the same thing for the fungus. It can insulate that. So if you've got a good snow layer, it's going to help insulate that fungus as well. And unfortunately, so it has to do with the temperature that the fungus is getting to on your plants. So
yeah, that's kind of what I was thinking. The other question I had, especially in the dryland regions, we're wet always, that Memorial Day time, first week of June, and everybody gets all up in arms and starts spraying, and then it gets hot about a week later and dry. And we always debate down here, did the fungicide help or did the heat help? Is there any recommendation on that? If you got hot and dry temperatures a week out, are you wasting your money with an application usually it's at heading time, flag leaf to boot to heading type thing?
yeah, I know on my variety trials, when I've got the ability to put my own fungicides on, I'm pretty conservative in applying fungicides, and I do really watch that weather. And it depends on the genetics of the variety you're growing. I mean, I'm growing a whole trial, and part of me wants to see a little bit of disease, so I know which varieties are potentially going to get hit earlier in the season. But in a commercial setting, I guess know what resistance your varieties have. If they've got some adult plant resistance, you've got warming trends, and you've got warm weather coming, and you don't have a lot of disease present in the field, I would probably tend to hold off on application. I don't think it's necessary because, as soon as those temperatures start increasing, the fungus just shuts down.
Right.
And those spores actually can't survive when the temperature starts getting warm enough as well. So.
Yeah, I think that's a great message. Know what your environment's doing to you, because I think there are ways, just like it's like with the action of herbicides as well. You can take advantage of the resistances if you've got good temperatures coming from your favor. So why not take advantage of it?
Sure. Okay. Anything else on stripe rust, or should we transition over to soil-borne mosaic?
Well, no, let's talk about the new one. That's always more fun.
Okay. So just a little bit of background. The soil-borne mosaic, soil-borne wheat mosaic virus has been identified in the country for over 100 years. It was originally found in the Central Plains states. Its first identification in the PNW was in the Willamette Valley of Oregon in about 1994. By 2005, it had been found in the Columbia Basin of northern Oregon. 4 years later, it was found in Walla Walla County, just across the border in the Walla Walla region, and has since been found in a couple other areas of Washington. But we had our first confirmed identification of soil-borne wheat mosaic virus in Idaho in 2023. And it was just due to some really diligent crop consultants that happened to spot these odd patches out in the field and send some samples in. Doug Finkelberg and myself did some concerted efforts in the summer of 23 to really alert growers and some of these crop consultants to the presence of this new disease, what to look for, when to sample. And last year we had some additional identifications, 4 additional fields down in Idaho County, as well as a few additional fields in Nez Perce County. So I don't want to give the impression that this is spreading and really blowing up, but I think it's a matter of we are now identifying that this pathogen's present. It's probably been here for a number of years. We're just now recognizing it. I'm going to show a picture here of what the symptoms look like. Let's see. If I can find my, yeah, maybe I can't find it. Well, I cannot find my PowerPoint screen. Anyway, I'll describe what the symptoms look like. So, early in the season, we're going to see these patches. So early in the season, I'm talking March, early April, we're going to see patches out in the field that are going to be kind of a pale yellow or pale green color, pretty distinct patches. The issue is that it can resemble a lot of other things. You may think it's, nitrogen deficiencies, or maybe a waterlogging area of the field, or maybe it's some Pythium root rot. Could even be barley yellow dwarf that you may confuse it with. In fact, one of the fields I went to in Idaho County this last year, I was convinced it was barley yellow dwarf we were dealing with until we sent the sample into the lab and had it confirmed as soil-borne wheat mosaic virus. So there's a lot of things that can be confused with. I can't go out to the field and definitively diagnose something as a specific virus disease. You really have to take a sample, send it to a diagnostic lab, and have it tested for viruses or for that specific virus to know that it's there. But the sampling also needs to be done when you see symptoms in the field. So I guess just back up a little bit. This particular virus is impacting winter wheat specifically. It can infect spring wheat, but the conditions that are required for the virus to replicate are usually not in place. It needs really cool conditions, and it's usually getting warm enough by the time the spring wheat's developing. So we don't see a lot of disease in spring wheat unless you were planting it in the fall as a facultative wheat. So we're seeing an infection occurs in the fall when temperatures start dropping below about 50 degrees. In the spring, we see symptom expression when temperatures are between about 35 and 50 degrees. So it's going to be in that mid to late March into the early part of April. Once the temperatures increase up to about 65 degrees, the virus actually stops replicating. It shuts the virus down. And plants may have been that were symptomatic early in the season are going to appear to have recovered. Those patches in the field will green back up again. The rest of the season, you may not even be able to see that patch by the middle to end of May. If you're going to sample for this, you have to sample when there's symptoms in the field. If the patches have disappeared, you're not likely to find the virus in the field. Now, damage from this virus can vary from year to year in these patches. When we have really long, wet, cool springs, that prolonged cool in the spring, we have a lot of temperatures below 60 degrees. We can have more virus accumulating in those plants and subsequently more yield loss. If we have a very cold winter and then we suddenly go to having a warm spring, very short window of those cool, wet conditions, we're going to have less disease occurring. One important thing to mention with this virus is it's transmitted by a fungus-like organism called polymyxograminus. So that's what's transmitting the virus to the wheat. That particular fungus-like organism, polymyxa, can persist in the soil indefinitely. So once it's introduced into the field, it's what they call an obligate plant parasite, meaning that it parasitizes the roots of whatever crop is growing in the field. It has a very wide host range, whether that's wheat, barley, peas, lentils. It can colonize all of those. Polymyxin itself does not cause damage to the plants. It's the fact that it's transmitting the virus that causes the disease and issues in wheat. But once you have it in the field, it doesn't go away. So if you have a patch that may be more or less obvious in one year versus another, but it's going to basically persist there indefinitely. And there's no practical way of getting rid of it. Now, solutions for this first and foremost, we're not in a situation yet in Idaho where we need to be concerned to the point where we need to be planting every acre with some sort of a resistant variety. But we need to be aware that this virus is out there. If we see patches that we can't explain, we should be taking a look at those and potentially getting those tested. The disease isn't going to blow up and be, again, going from fence row to fence row, but we need to be aware of its presence. It's going to be primarily in lower lying areas of the field or in wetter parts of the field. It could follow tillage strips or directions of your drill. So anything that's going to move that soil is going to potentially be moving that vector and subsequently moving the virus. So whether that's, your sprayer going through the field or a planter or a pickup or a four-wheeler, anything that's going to move soil, particularly in the spring when you've got really wet soil out in the field, is going to potentially be moving that fungus around within the field and to neighboring fields. So I think monitoring, being aware this disease is there, if you find something suspicious, get it tested. The next management strategy that is recommended for this is sanitation. And I know with the scale of equipment we're dealing with the amount of acres we're trying to cover in the spring, that can be really challenging. How do we sanitize? How do you spray down a 50-foot drill, clean it up before you go to the next field? That may be impractical. But one thing you may think about doing is if you have fields that have soil-borne wheat mosaic virus in them, plant those fields last and get to those fields last in your operation, then clean your drill up before you do your operations in the next season. So that may be one strategy that we can incorporate some sanitation without it being a real onerous issue of cleaning equipment between all the fields. The other thing I should mention is there's really good genetic resistance for soil-borne wheat mosaic virus. There's a couple of dominant genes that are used globally in areas where soil-borne mosaic virus is an issue. Unfortunately, we don't have those genes in a lot of the germplasm we grow here in the PNW. It is in a handful of our varieties, but I know it's something that's on the radar of our breeders, and I know particularly at Idaho, I believe WSU folks are working on this as well, but they're working on integrating some of these genes into, or at least looking at the genetics we've got, but thinking about incorporating some of these genes into adapted varieties so we have those tools available on the shelf if we need them in the future. I think for the most part right now, all these patches are probably small enough in the field. You don't need to be thinking about planting a variety that's not necessarily going to be the best variety, but resistant to this virus. But we need to be thinking about that down the road. And, we start getting larger patches that are, encompassing a half an acre, an acre. I think it's something where we need to think about either planting those parts of the field a resistant variety or having a blend that has a susceptible and a resistant variety. So when you plant across those patches, you've got something to carry you through.
Yeah, Kurt, I think the sanitation aspect is an important one right now. I know it's not easy with the kind of equipment that folks are using right now, but that is the way the way the virus moves is by moving the soil. I assuming windblown soil can also carry it, but it's really going to be more predominantly machinery in the short term. So knowing what you've got, knowing what you can avoid getting into is also going to be very important. The Midwest has been dealing with this, as you know, for decades, and luckily the resistances have been strong and they've held. So as quickly as we can, we're trying to get those identified in the programs and get them increased and available to growers that are going to need them as quickly as possible. Like you say, there's only a handful of varieties out there right now. We're hoping to resolve that and get more in their hands quickly, but it's going to take us a couple more years to get those out of the Northern Idaho program and really get them deployed very well. So it's going to take a little bit of time, but at least we have some resources we can turn to in the short term to try to hopefully minimize the spread or minimize the losses.
So any questions on, yeah.
Just a quick question.
Oh, go ahead.
I just wanted to ask how the PNW compares with other regions. I know, Jim, you mentioned the Midwest, but surrounding regions of the PNW, is it comparable? Are they seeing issues?
I'm not entirely sure. Jim may have a little bit better sense of this, but I know they've been dealing with this in Oregon now for almost 20 years. And I think where it's really problematic are in fields where it's irrigated, and so the entire field is pretty wet. And those are areas where it can be more of a concern because you've got a condition that can be conducive for that fungus-like organism, the vector that moves the virus around. But I think it's, the patches are probably spreading. But again, they're being restricted to areas of the field where, it's generally going to be in low-lying areas. It's going to be in areas that tend to stay wetter into the season. That doesn't necessarily mean that's where it's going to be restricted to, but that tends to be the case. But we're not to the level that they're dealing with in the Midwest yet. We're to the point where there's some fields that we need to be thinking about deploying resistant varieties, particularly in Oregon and Washington right now. But we're not to that point here yet in Idaho. I think right now in Idaho, we need to be thinking about identifying the disease, using sanitation where we can, and moving forward from there and just monitoring those patches. At some point, we're going to have to start putting resistant varieties in some of these fields, or at least in portions of them. But I think that's down the road for the most part.
Sure.
But you're right. I mean, in the short term, it's monitoring this thing. It will not go away. It will only spread. The only question is how fast is it going to be spreading, and how quickly can we develop the varieties to give folks that need it that resource. But it'll take a little bit of time.
Yeah, and unfortunately, this isn't one of those. I mean, a lot of our plant diseases, we usually point to crop rotation. That's usually a good way to get away from some of these diseases. Unfortunately, and because polymyxa is an obligate parasite, it's going to parasitize just about everything we grow on the rotation. That's not a practical solution. So, whenever we grow winter wheat, those patches are going to be in the field, and depending on the year, to a lesser or greater extent.
Say, Kurt, you mentioned a couple other viral diseases as well. Do you have a couple others that you are personally concerned about spread, or just see periodically, or growers ought to be aware of?
Well, the other viral disease that I've seen, I shouldn't say commonly, I see it every couple of years, is barley yellow dwarf.
Yeah.
That's another one of those diseases. It's an aphid vector disease. So if we start planting before we get a good freeze in the fall to knock those aphids down, we have the potential, if there's very viridiferous aphids running around, that could infect our alfalfa seeded wheat. It's not something I see very commonly in North Idaho. I think it's something that's probably more common maybe down the southern part of the state where it's irrigated, or parts of central Washington where they're seeding in early September when the temperatures are still pretty warm. They're seeding into moisture and have pretty big plants going into winter. But for the northern part of the state, I see barley yellow dwarf every once in a while, but it's usually pretty patchy.
We're pretty lucky. We don't really have wheat streak mosaic, the curl mite vector disease, maybe a little bit in southern Idaho, but that's
there's a little bit of it around, but
disease.
it's not one I've seen very much.
And spindle streak is the one that's kind of complementary to soil-borne mosaic, which has become a problem in Kansas. When you have both diseases, it takes a different set of resistances. Luckily, we don't have that combination, so we're kind of dealing with a simpler problem right now than a lot of our colleagues are in Kansas and Oklahoma, for example. So let's hope we can keep it that way.
Right.
Yeah.
Yeah, barley yellow dwarf is kind of a continual problem in dryland areas where we plant in mid-August down here. I pretty much don't put anything in the ground with a neonic on it for aphids, for BYD. But another one I see pretty commonly even in the dryland is tan spot early on. And I debate yearly on a low rate of fungicide application or herbicide timing for tan spot. And I don't know, I've tried strips like every other pass, those kind of things. And I have a hard time quantifying a response to it. But at the same time, like a lot of things in southern Idaho, we start to get drier and these diseases kind of remedy themselves. Do you have any thoughts on tan spot and its potential problems?
That's a disease I have rarely seen, so I should know more about it than I do, but I unfortunately don't really have any recommendations on that one.
There are definitely differences in varietal responses to tan spot, and some will give you some pretty decent resistance. The thing you'll be a little bit careful about, there's also a physiologic leaf spot out there that can also be confused sometimes with tan spot. And in some of the backgrounds of the varieties we have, it's been hard to get rid of that leaf spot disease. Well, the physiologic leaf spot is not a disease, but getting rid of the background sometimes has been difficult. Doesn't really cost you yield, but it is kind of ugly looking sometimes. So knowing whether you really got the tan spot disease or whether you got a leaf spot, a physiologic leaf spot, or something else sometimes can be a little bit of a challenge too to diagnose it.
And that is very true. We often have very cold nights, around that same time, and you try to diagnose whether it's just weather or whether it's a disease. And
right.
I don't know, it's tough. But one more comment on BYD. For a while there, I grew Zerfa because it was just a dang good yielder. But holy cow, its susceptibility to BYD was so like side by side with some of the other varieties. I want to think it was Auto and a few others at the time I was growing. It was night and day difference. Like you could see from miles away where the purple in the leaves were and where that varietal line is. So I just want to emphasize that, variety, selection is huge in the BYD world, I think.
It's not always easy to get notes on the diseases like that either, which is, sometimes a little frustrating.
All right, Kurt, some great information there for us. Great. Thank you so much.
You bet.
Appreciate that. We are coming up on our end time. I just want to thank you and everybody for joining us today. And just a reminder that we will post this podcast to our website and also our YouTube and Spotify channels. So if you want to go rewatch or share it with your friends, fellow farmers, we would love that. Also want to remind you to join us back here for our next From the Field that's scheduled for February 6th. We'll be talking with Jared Gibbons from Extension up in Eastern Idaho, talking about his research with wheat and water and his drone study. So that is slated for March 6th. So we hope to see you back here. Thank you again for joining, and we'll see you next time.
Thanks, Kurt. Take care.
Thank you.